yeah, an example. And hopefully this will make for a nice little closing touch to the lecture, because here I will actually explain to or show to you, this is from a research paper, okay? An actually, I'm not sure if it was published, because last time I checked, it was more than a year ago. It was not published yet, but it was on the way to being published. So I guess by now it's already published. It's a paper called Street Style, and it shows an application of clustering for analyzing fashion trends, right? So basically, it's an analysis of clothing and fashion across millions of images of people. So there's millions of images. They gathered all these images around all the world and spanning also several years. So there's a lot of data from a lot of different places and also in different times. And then the idea is, can we detect some clusters here? Can we analyze this data set in such a way that we can find groups of, you know, people who dress the same for whatever reason, either for geographical reasons or for periods of the year, for example, or some years you had a specific fashion and the other years you have different fashion styles. Anything that could be found in this data set by using clustering, right? And so basically this is an example, and each of these sets of pictures that you're looking at is one cluster. And you can see here, like, this is a cluster of guys wearing white shirts with some kind of a drawing in it, or some figure or something, and you have a bunch of others. So let's take a look at the results that they get in general. These are some examples of clusters that some of the clusters that they got with the lowest space-time entropy, which basically means that they have clear patterns, right? So entropy, if you don't know how entropy is, it's hard to explain, but just think of entropy as being like something random. Something random has high entropy. The more something is random, the higher the entropy of something. It's a very general concept. So if we're looking at something that has low space-time entropy, that means that the results are far from random. So there are patterns there to be found, probably. So it's very interesting to notice patterns by city and by month. So the graphics, so we have 5 clusters. These clusters are, these heat maps over here that we're looking at, they show the month of the year from top to bottom here, January to December. And then the cities in the horizontal axis. Unfortunately, it's very small. Maybe I should put them larger next time, but these are just capitals of many different countries in the world, okay? And for example, okay, so then you have a cluster. There are millions of data points in this data set, so every cluster has probably hundreds of thousands of points, or at least dozens of thousands of points. So as an example, the people that you see here, the pictures, are the people that are closest to the centroid. So this is one way that you can, you know, give examples of elements from your data set. You just take the ones that are closest to the centroid of the cluster, because probably these are very representative. If they're closest to the centroid, then that means they're very representative, right? And then of course, just by looking at this, you can see the patterns here. It's not perfect, but you can see it. And the interesting thing is that you can also take an average. So you take all the pictures of the cluster and just average the pixels in them, in all of them. And then you end up with some quite interesting pictures on average. It almost looks like a person. It's kind of weird, actually. It's not a person, but it looks like a person. It's just an average of dozens of thousands of persons in one picture. But you kind of look at, it gives you a little bit of an idea of what's in the cluster, right? And the important part for you guys to understand related to this lecture, of course, is that this cluster, I mean, we had to cluster it before we could do these things, right? So I'm not going into details here on how they clustered, because it's a little bit involved and it's kind of like a mix and match of many things. You can look at the paper if you're curious. It's very advanced, very interesting. I wanted to show you more like the intuition about what do you do with the clustering once you have it, right? So it's very interesting because first you have to cluster, and then after you cluster, you can take the people that are closest to the center of the cluster, which are interesting. You can take an average of all the people in that cluster, and then you got this weird thing over here, which is kind of looks like a human being, but it's not. But it does give you a lot of interesting results. Like, for example, these are obviously women. I can, in my opinion, it's obviously a woman. And also you can see that from the pictures, actually. This woman is wearing something in her head, some kind of a head or something. You know, each of these are using different things, but they all have stuff in their head, some kind of a head or some kind of a thing. As you can see, on average they're using very light colors, light pink or something, and they sound like it's almost like they're smiling in general, because this picture here looks like it's smiling. And then you get this. So that's one way to kind of like describe your clustering. And finally, this thing here gives a more detailed perspective. And look how interesting this is, because if you look at the vertical stripes, that means there's a certain pattern that is very strong in one city, because this is one city. This is actually Lagos, the city of Lagos, and this is, so it's very it's very clear that this pattern over here that this cluster represents is very, very strong in Lagos throughout the entire year, because it doesn't change. I mean, it changes a little bit, but not much during the entire year, and not everywhere else. It's very weak in the whole world, but it's very strong in Lagos. So this could represent, it's not only people from Lagos, obviously, because I guess this woman is probably not, she looks like she comes from India, maybe. So it's obviously not only from Lagos people, but it's very clearly a pattern in Lagos throughout the entire year for women to kind of use some kind of a hat or this fabric on her head. I'm sorry, unfortunately, I don't know what it's called, but it's very beautiful. And so it's a Lagos thing. And then for the next one, for example, then you can see this is for it's also a very clear pattern in other cities. And unfortunately, I'm not sure exactly, but I think it's Cairo and Jakarta. So these are two other cities in the world, and it's a very clear pattern for these two places. And it's also slightly good also for Istanbul. I think this is Istanbul, if I'm not sure, if I'm not mistaken. So it's also a little bit strong in Istanbul, but not everywhere else. And then you look at these, and you can see these are, you can see the pattern here that is related to these places, which is very interesting because it doesn't change much in the entire year. And here you can see it's a bunch of guys wearing soccer, how do you say that, jerseys, I think. Yellow soccer jerseys. Some of them are from the Colombia, I think this is the Colombia national team, this one. And then there's obviously this from Dortmund, I think that's it. I'm not a big on football, guys, but I think this is Borussia. And it's very interesting to see that actually this pattern is not the entire year. It starts in June. It's very, very strong in June. And then it kind of goes down a little bit to the end of the year. So again, I'm not a very much a football guy, but I would guess that these are football seasons, probably, starting in June, and then somehow this represents a period of the year where you get more soccer games, I would guess. I'm not sure. And so on and so forth. And then this one is also a very interesting pattern, which is that it's actually not present in the entire year, right? Oh, sorry, in the entire year. It is more or less common in the whole world, not exactly in the whole world, but in many different places in the world. But it's very strong in January and December, but not very strong in the middle here in June. And if you look at the pictures, then you can see these are winter clothes, right? Actually, in the average picture, you can already see that these are winter clothes. That's very clear, I guess. And it looks like a woman to me, but I'm not sure. It's not necessarily a woman, but it's definitely winter clothes. But as you can see, in places where winter is, you know, in December and January, then summer is in the middle here, June, July, and August. Then you don't see it anymore, and then the pattern comes back towards the end of the year, which is quite interesting. Yeah, so Tito said maybe World Cup. Yeah, maybe there was a World Cup in this specific time when they took this data sets. Yeah, I guess that's a good guess. So these are very interesting. So what's the point here? Why am I showing you this? The point here is to show you what do you do with the clustering, right? So you can show some examples of data points from a cluster. You can show the average data point of a cluster. You can show the patterns that happen within a cluster. But the most important part is that before you get to this, you have to actually do the clustering. You have to actually partition your data set into meaningful clusters. And then you find these. And this is completely exploratory data analysis, right? This is, you're exploring the data to see what is in it. You don't know beforehand. You didn't know what was in it before you started, and then you found it. And these are an example. This is the other end. These are style clusters with the highest space-time entropy. And just by looking at these heat maps here, you can quickly understand what the high entropy means. Like, just compare this with this, right? This looks random. These are probably patterns that cannot be attached to any specific time of the year, and also not to any specific place in the world. They're just everywhere, right? And then you see, you know, people wearing red t-shirts with drawings in them, like band t-shirts or any kind of red. Did I say red? No, black. Black t-shirts with some kind of a drawing in them. This is just a general pattern that you can find anywhere in the world, any time of the year. And other, like this one is very interesting. It's these clothes with, how do you say this, chess patterns, checkered, I think, checkered patterns or something like this. This is also something that's super random. You can find that anywhere in the world, any time of the year. And it's even hard to determine to see this in the average. This one is very interesting. You can see it's very clearly a person using a black t-shirt with something in it, even though it's very blurry, and so on and so forth. So mostly black t-shirts, mostly black t-shirts. And I guess we could probably, you know, think that you wearing a black t-shirt like I am right now is a very random pattern that cannot be attached to any time of the year or any place in the world. And you know, this is also an interesting thing that you can come up with from your data set. I mean, you don't have to necessarily just look at the low entropy specific clear patterns. You can also come up with, so, you know, wearing black shirts is a very common thing everywhere in the world any time of the year. That's also a very interesting conclusion that you can take from this data set by looking at this kind of clustering. Now we're over. I hope that was interesting. So this isn't supervised learning, guys. This is the kind of things that I do research on. I personally think it's very interesting. It's very challenging, and there's always a multitude of challenges and things to be done regarding this. And there's also so many applications that you can do. You can see the references. Of course, you will have access to the slides, so you can take that. Chapter 9, I forgot to put the chapter here. I guess I'm going to change the slides to show the chapter. But chapter 9 of the book from Geron deals with clustering specifically. There's also this other book, number 2, which is an introduction to statistical learning with applications in R. This is, correct me if I'm wrong, but I think this book is also freely available online. If not, there's another book called Elements of Statistical Learning by the same authors, which is available online. I think this one is also. I should have probably put the link here. I think I'm actually going to put the link here before I publish it. But this is a very interesting, slightly more mathematical approach to machine learning and clustering. And that's where all the formulas that I used come from. But it's also a very interesting book. I suggest taking a look at that. And then some other lectures and some other papers and stuff. Thank you very much. That's it for today.